Francis.
Very good. And the pumps, can you see the pump picture?
Yeah, this because of the pump picture. Well, I can.
Yes, sir. Yes, sir.
Okay, so did you all get the calculation done? Approximately how much oil on the tank top?
In the chat, someone is saying 4,500 liters.
Okay, not so bad, but okay. So half a liter per revolution. So into 100 and 3 minutes. Into gear ratio. I did not tell you this pump will not rotate at 100 rpm. I said engine running at 100 rpm. So generally these pumps will run at least 12 times the engine rpm. Can also go up to 17 times. So which means bigger engine we can have 17 times engine rpm. Otherwise, smaller engine up to 12. So we need to put a gear ratio, let us say 50, will come to approximately 5,000 liters of oil. So it will take not much time to empty your sump tank if you got a major leak. So that is why we've got alarms and stuff like that. So you need to be quick, and you also need to do good inspection of the piping system. Okay, so that's the HPS system. That's your sprocket. And that's one pump. Second pump, like that, there are 3, maybe there will be 5, depending on engine size. Can you see a little sharp, long shaft here? This shaft is nothing but we call safety shaft or the weak link. This is about a duplex chain, 4-inch, of course. There are 2 chains here. Bigger engine will have more power requirement. So then, of course, we need to have that wrench. The drive is coming to this main shaft, from there to the gear, transmission to the pump. If your engine is more than 90 bore with more than 3 pumps, then all the pumps are not put on one side, they are put on either side. Some of them will be clockwise rotation, some will be anti-clockwise. So what they will, in that case, will have 1 pump spare and 1 pump of this kind spare in the engine in the position. So there is not enough place to put 5 pumps on one side. So that is why we have to split them into 2 and 3. So that's your safety shaft. So the drive which is coming from the engine here, here, coming through this line, and here we got the pump. So it is flying here. When the engine rotates, this also will rotate. It's a gear engine. Yeah, it's a gear engine. Keep rotating, pump also rotate. It's absolutely no problem. But when there is a misalignment happening between the driving end and the pump end, so this will start bending. Then there will be stress coming here to the friction disc. So this part will snap. When this snaps, which is the weakest link in the system, this drive will rotate, but not the pump. So that is how the pump is protected from damage. If this happens, you need to replace the full safety shaft, which is given as a spare. Full thing has to be given. But I must warn you, if this has happened, you need to do a thorough inspection of your driving mechanism, chain or the gear, why the misalignment has come. Otherwise, you will again damage this. To be careful about this. And when you fix this, there's a torque tightening required here, that is in the refer to your book. No grease, only system oil has to be. There's another HPS system, which is Mark IV, latest one, with more accessibility, more accessible, more what do they call it, ergonomically better, with hoses and piping. You can have hoses here, no problem. If you've got a hose in the system, the hose has to be replaced in 5 years' time. So there will be a data manufacturing here. So you need to change. But at the same time, you may have some hoses in the storeroom. So that also has to be replaced when the data manufacture process 5 years of time, because they also due to depletion, due to aging, they get damaged. So all rubber products, which includes hoses from the system and the storeroom, has to be replaced in 5-year calendar days. Okay. So the other rubber product that we can see on the main engine is your accumulator bladder. So that also has to be replaced in 5 years. Question? Okay, so now I told you we've been talking about continuous improvement of the main engine. We have moved from 200 bar to 300 bar. So when you increase from 200 bar to 300 bar, what is the advantage? You don't need so much of quantity of oil. The flow rate can be controlled. So I can reduce the flow if I increase it. If I increase the flow, I can reduce the pressure. So, but it is better to reduce the flow because oil is quite expensive. We need a lot of oil. So we don't need more pumps also. So we have pumps which has got capability to pump up to 300 plus bar. So then I can reduce the flow. So that's what they have done it here. So unless you go for a 90 bore engine with more than 7 cylinder, you will not see more than 4 pumps or 5. So this is the arrangement for a 200 bar system and a 200 bar system. You can see that here. This is the 200 bar system. You can see here the 4th pump. This is only 3 pumps and the pressure is 225 bar. So when the starter pump running also, or when without the engine to pump, this pressure should be 225 bar. And for starter pump, the pressure is 175. You can see this is only 196 bar, less pressure, but I require 4 pumps. Very high pressure, so I need only 3. So this is the basic difference between a 200 bar system and a 300 bar system. And there will be no double wall pipe here, leak here for a 200 bar system, but there is nothing like that on a 300 bar system. So that's another main difference. So yesterday I mentioned the leak valve pressure here. This is a 200 bar system. This is 175, 230, 250, 225, 310, and 250. Here at the inlet side, we have got an alarm and we also got a shutdown. There is no slowdown. The alarm is at 0.7 bar, shutdown is at 0.5. So below 0.8, so 0.7 bar is the alarm. It will be very fast, huh? So keep that in your mind, 0.8, 0.7 bar and 0.5. There is no slowdown, only shutdown and alarm at 0.7. On the discharge side, you have got this is a non-cancelable shutdown. On the discharge side, we also got another alarm, another shutdown. So for a 200 bar system, which is 145 bar and below, engine will shut down, and this one 175 bar and below, engine will shut down. But however, you verify these figures with your engine specific instruction book. This is the standard value by the way. So before the pressure comes to let us say 145 bar, your engine RPM would have come down. How? There is a hydraulic power supply limiter, which we discussed on the second day and first day. So let us consider now there is a major leak like you calculated. Let's say leak from here. So the set point is 195 bar. Who decided the set point? The software. So software decided 195 bar. So these pumps will do the job exactly what is been asked to do. It will go to 195 bar slowly. But of course, here there is a leak. Then what will happen? These pumps do not know there is a leak here. It will keep on increasing software angle, and it will keep on maintaining the pressure. At the same time, your bilge engine room bilge tank also will keep filling up. So there's a major leak here. Okay. So at a particular place, let's say a point where the pressure is only 185 bar, that's only the pump can build up.